Hello friends, after a very long time, welcome back to Align Pattern. In last lecture, we had seen what is deadlock, what are the conditions and methods to handle deadlock, right? If you didn't watch it, then please check that video once for better understanding. Now today, we will see what is Banker's algorithm comes under deadlock avoidance, and we will also solve the problem based on this Banker's algorithm. So, what are we waiting for? Let's get started to our session. We know deadlock is the situation or condition in which two computer programs sharing the same resources are effectively preventing each other from accessing the resource. And we also know from the previous video that what are the four conditions for deadlock, that is mutual exclusion, hold and wait, no preemption, and circular wait. Right. We also learned deadlock could be handled by the four ways: deadlock ignorance, deadlock prevention, deadlock avoidance, and fourth one is deadlock detection and recovery. Right. And always make in mind that our banker's algorithm comes under the method deadlock avoidance. Okay. That we will learn today. So turning to Banker's algorithm is the resource allocation and deadlock avoidance algorithm, and it is mainly used to avoid deadlock and allocate resources safely to each process in the computer system. In simple terms, we can say that it helps the operating system to successfully share the resources between all the processes. Got it? As the algorithm's name suggested, this banker's algorithm mostly used in banking sector. Keep it in mind, okay? To check whether the customer's loan could be sanctioned or not. Suppose there is particular bank like XYZ, and there are multiple customers, or we can say bank holder, like there is n number of bank holder, and of course this bank would have some amount of money to distribute, right? Suppose this XYZ bank have total money TM. Let's say one customer or one account holder named John applies for loan in bank, and in the same XYZ bank, let's say another bank holder Lily applies for a loan or withdraws some amount of cash from the bank. Okay. In such case, XYZ bank first deducts the loan amount from the total cash and then estimates the cash difference as more than total money TM to approve the loan amount for the first bank holder John, so that bank manager could help Lily to withdraw some cash or applies for loan at the same time without any restriction in the functionality of the banking system. Got it? Same fashion works in an operating system. When a new process is created in a computer system, the process must provide all type of information to the operating system, such as upcoming processes, requests for their resources, count and delays. So based on these criteria, the operating system decide which process sequence should be executed or waited, so that no deadlock occurs in a system. Got it? There are key points to remember in Banker's algorithm. Like, we have a limited resources in the system. If any process requests for a resource, then it has to be wait. If any process gets all the needed resources, then it should return the resources in a limited period. Resources should be maintained so that the request of one customer or one person holder in list is fulfilled. Got it? Mainly, Banker's algorithm is consist of two algorithms. First one is safety algorithm and second one is resource request algorithm. The main motive to remember is that safety algorithm is an algorithm used to find whether the system is in safe state or not. Okay, and resource request algorithm is mainly used to determine whether request can be safely granted or not. Just remember this. Okay, let's get deep in this with the example so you better understand. As I said earlier, safety algorithm is used to check whether the system is in safe state or in unsafe state, right? There are four steps in this algorithm. Suppose we have n process such as P0, P1, P2 to Pn, and let work and finish be vectors of length m and n respectively. So in step 1, we set finish of n equal to false and work equals to available. Okay, so what does it mean? That finish of n, which we can say arrow of flag, that is all flag are set to false initially, and work is set to available, that is the number of available resources instances corresponding to each resource type. Got it? Suppose there are three available resources A, B and C. Okay, like A is resource printer, B is resource scanner and C is any kind of RAM. So availability of these resources could be like this: A is having 3, B is 2 and C is 1. Okay, this is the availability of the resources. So take work and assign available resources variable to it. When we take actual example, it gets more simplified. So just concentrate on the step of this algorithm first. Then the next step is find an index of I process such that finish of I is equal to false, need is less than equal to work, right? Here we have to remember the process need is less than what are the total number of available resources, and finish I means the process initially has not been allocated to any resource. If no processor is available, then you can jump to step number 4, that is the exit of the algorithm, which we will see. Okay, in simple manner we could say that if the flag is not set to false, it means that the processor have been worked, or if say need is not less than equal to work means available resources is less than what we need, so we can exit the algorithm, otherwise we can do the step number 3. What is step number 3? That is the work is equal to work plus allocated, that is allocated means the allocation of resources to a particular processes, and finish of I is equal to true. Okay, let's say process P1 is initially allocated 2 resources, but it might be need of 4 more resources. So in this condition, what we do is step number 3, right? And turning to again step number 2 to search again for the next such process whose need is less than work and flag or finish is false. That is, it has not been processed. In such manner, we just trying to find particular sequence in which we can fulfill the need of each and every process. When an unfinished process is found, then the resources are allocated and the process is marked as a finish. And then the loop is repeated to check the same for all the processes. You get that, right? What I am trying to convey you. And after that, just go to step number 4, which is if finish of I is equal to true for all the I, that is eventually true for all the n processes, then the system is in safe state, otherwise system is in unsafe state. Got it? That means all the processes are finished, and if you note down the order in which you process those processes, that will give you the safe sequence. Okay, I hope this explanation of SETI algorithm is well understood by you. If not, then let's learn through one simple example. Suppose we have a 3 resource A, B and C. A is resource having 10, B is having 5 and C is having 7 counting. And we are having 5 processes P0, P1, P2, P3 and P4. Here, allocation block specifies the resources currently allocated to each process, and max block specifies the maximum demand of each process. Now we have to find out how many available work or available resources is there. So concentrate on allocation block. We have process P0 to P4 and 3 resources A, B and C. Resource A is having 10 counting as we have seen here earlier. So out of 10, process P1 occupied 2 resource. P2 occupy 3 and P3 occupy 2 resource, right? As we understood this by the given table, so out of 10, 7 resources were occupied, so remaining will be 10 minus 7, which is 3. So our available resources count for resource A would be 3. Got it? Like this. Same available resources for B is having count 5, right? So process P0 occupy 1 and P3 occupy 1. So total is 2 and 5 minus 2 is equal to 3. So same our available resource count for B is 3, right? Again for resource C, occupy count for P2, P3 and P4 is 2, 1, 2. That is 2 plus 2 plus 1 is equal to 5, right? So 7 minus 5 is equal to 2. So available count for resource C is 2. Got it? Now after calculating available resources, we have to find out need matrix. Need means additional resources that process is still required to complete the task, and it can be calculated as maximum value minus allocation value. Okay. So, for the process P0, need for resource A is 7 minus 0, which is equal to 7. So, we can write need for A is 7. Same for B and C also, same for process P1 to P4, right? Like this. Got it? Now, we have to find out the available work for process P1, right? For that, with the help of our algorithm, we have formula to check if our need is less than equal to work. So, for the process P0, need is 743 and available work is 332. So 743 is less than equal to 332. Here 7 is not less than equal to 3, 4 is also not less than equal to 3 and 2 is also not. So we cannot allocate resources for a process P0. Got it? As our condition is not satisfied, so moving on with the next processes. Again check for the process P1. For P1, what is need value? It's 1, 2, 2, right? So check 1, 2, 2 is less than equal to available resources 3, 3, 2. So this condition is satisfied. right? So we can allocate resources to process P1. So our new work value will be work plus allocation, right? So our new work value would be 332 plus 200, which is equal to 532. So our new work value would be 532. Right, now we are checking for process P2. What is need value for P2? That is 600. So 600 is less than equal to 532. So this condition is also not satisfied. That's why we cannot allocate resources to P2. Next we will checking for the P3. For P3, 011 is less than equal to 532. This condition will satisfy our need, right? So we can definitely allocate resources to process P3. So our new work value would be work plus allocation, that is 532 plus 211, which is equal to 743. Then let's go for process P4. For P4, 431 is less than equal to 743. It is also satisfied. So new work value would be work plus allocation, that is work value is 743 plus allocation 002, which is equal to 745. So out of 5 processes, first P1 enter into the safe state, then P3, and now P4 enter into the safe state. Here we have completed one cycle, right? Process P0 and P2 still not been allocated. So in next cycle we can move for the process P0. Okay, work value is 745, right? So 743 is less than equal to 745. Yes, it's been allocated. So our new work value would be work plus allocation, that is work value is 745 plus allocation is 010, which is equal to 755, right? So our new work value will be work plus allocation. That is 745 plus 010, which is equal to 755, right? Let's update in our box. So P0 is also in a safe state now, right? So last process is P2. Again check for P2. Need value for P2 is 600 and updated work now is 755. So 600 is less than equal to 755. This condition is also satisfied, right? So new work value would be work plus allocation. What is work value? That is 755 plus allocation value is 302, which is equal to 1057. And again process P2 is in safe state. So for the given problem, this is the safe state. First process P1, then P3, then P4, then P0, and last process is P2. Okay, so when the system allocates the resources in this sequence, it will be in the safe state. Will surely not go into the deadlock state. Got it? So this is the safety algorithm. I hope you understand well. Now we go for the resource request algorithm. What is resource request algorithm? Actually, a resource request algorithm checks how a system will behave when the process makes each type of resource request in a system as a request metric. In resource request algorithm, we have to follow certain steps as we have seen in safety algorithm. Okay, first we have to check, that is the request run by process is less than equal to need of it. If this condition is satisfied, then we move to the next step. In step number 2, we compare request with the available. If request is less than equal to available, if this condition is also satisfied, then we must go to the next step. In step number 3, we have to perform 3 actions like available is equal to available minus request of I, allocation is equal to allocation plus request of I, and need of I is equal to need of I minus request of I. And at last, in step number 4, check if the new state is in safe state or not. Okay, these are the common steps in resource allocation. Let's take the same example as we have seen in safety algorithm. We have 5 process P0 to P4 and 3 resource type A, B and C. A resource is having 10, B is having 5 and C is having 7 counting, as we have seen earlier, right? So as we have seen earlier, we have to calculate first need value as a maximum minus allocation. In earlier, we calculated our need matrix, so I have directly put it down counting here. Okay, so our need column would be like this, right? So here the P1 is requesting to 102. We have to solve this using the resource request algorithm, right? So our first step is request done by process is less than equal to need of it, right? So here request is 102 and need value for P1 is 122. Okay, so request 102 is less than equal to 122. This condition is satisfied, right? So we have to go to the next step. Compare request with the available. if request is less than equal to available. So request is 102 and available resources we have is 332. So 102 is less than equal to 332, right? This condition is also satisfied. So we move to the next step. What is step number 3? We have to check now the 3 condition. That is available is equal to available minus request of I. Then allocation which is equal to allocation plus request of I. And need of I is equal to need of I minus request of I, right? So for the available, what is available value? It's 332 and request is 102. So 332 minus 102 which is equal to 230. For the allocation block, allocation value is 200 and request is 102. So 200 plus 102 which is equal to 302. And for the need of I is 122 and request is 102. So 122 minus 102 which is equal to 020, right? So we have to update all these three value in our table. So our updated table would be like this. Okay. So our last step is we have to check whether this state is in safe state or not. To check this, we have to use safety algorithm. Okay, we know safety algorithm, right? First, we have to check for the process P0. In safety algorithm, we first check need is less than equal to work or not. Then we move to the next step, right? So here need is 743 and available work we have 230 as updated value, right? So 743 is less than equal to 230. This condition is not satisfied. So we move to the next process. So for the process P1, need is 0 to 0 and work is 230. So 0 to 0 is less than equal to 230. It can be allocated, right? So new work value would be work plus allocation. So work value is 230 and allocation is 302 which is equal to 532. So our new work value would be 532. We can update it in our table list, right? So we can add P1 is in safe state. Next we check for the process P2. For P2, 600 is less than equal to 532. This condition is not satisfied. Then we go for the next P3 process. For P3, 011 is less than equal to 532. This condition is satisfied. So work value would be 532 plus 211 which is equal to 743. Update our new work in the table like this and P3 is in safe state. Okay. Then the next process is P4. For the P4, 431 is less than equal to 743. This condition is satisfied. So new work value would be work plus allocation, that is work is 743 plus allocation value is 002 which is equal to 745. So we will change work value to 745 in this table and the process P4 go to the safe state. Again we will go for the process P0. For process P0, need is 743 and available is 745. So 743 is less than equal to 745. This condition is satisfied. So new work value will be work plus allocation, that is 745 plus 010 which is equal to 755. So we can update this new work value in our table and process P0 is going to the safe state now. Next remaining process is P2. So calculate for the process P2. So for the P2, 600 is less than equal to 755. This condition is now satisfied, right? So new work value would be work plus allocation, that is 755 plus 302 which is equal to 1057. So 1057 will be new work value, right? So 1057 that we got the available resources that we seen in earlier resource count, right? So in safe state we are going to add P2 process at last. So this is our safe sequence. I hope you understand both the safety and resource request algorithm well. So practice it and make good score. See you in the next session.